Hydrolysis. Hydrolysis usually means the cleavage of chemical bonds by the addition of water, where a carbohydrate is broken into its components sugar molecules by hydrolysis. For example, sucrose being broken down into glucose and fructose. This is termed saccharification. Generally, hydrolysis or saccharification is a step in the degradation of a substance. It's a video of saccharification.
Had an interesting question on Facebook the other day. The question is, what is hydrolysis? What does it even mean? Well, to put it simply, if you're breaking apart a molecule by reacting with water, it's hydrolysis. If you're starting with a single molecule, I guess it could be more than one, but if you're starting with a molecule and you're putting it with water, and in the end this molecule is broken somewhere, hydrolysis. That's how it works. There are three main examples I'm going to show you. The first one is hydrolysis of esters. Now, I don't have to show you, or I don't necessarily even want to show you, the mechanism behind this, but long story short, the oxygen will attack this carbon and end up breaking this bond. What happens in the end is you end up with your CH3CH2.
Well, types. Usually, hydrolysis is a chemical process in which a molecule of water is added to a substance. Sometimes, this addition causes both substance and water molecule to split into two parts. In such reactions, one fragment of the target molecule or parent molecule gains a hydrogen ion. It's another video.
Here's a brief review on hydrolysis and dehydration synthesis. Remember the words. Hydro means water. Lysis means to split. So hydrolysis is to split using water. Dehydration means you lose water. Synthesis means to build. You have to get synthesis into your brain for this course. So dehydration synthesis is to build molecules using water. Let's look at dehydration synthesis. What we have here is a monomer and another monomer that when they react together chemically, what we get is we want to try to get these two molecules put together. But we need some space, we need some bonds to break so we have bonds that we can join again. So let's take the water off, and the water will join together. And when I'm saying let's take the water off, we don't have water here, we just have a hydrogen and oxygen, and over here we have just a hydrogen. So if you pull the hydrogen and oxygen off of the one monomer and the hydrogen off the other monomer, you're going to get water. So that's what I mean by pull the water out.
Well, salts. Common kind of hydrolysis occurs when a salt of a weak acid or weak base, or both, is dissolved in water. Water spontaneously ionizes into hydroxyl anions and hydrogen cations. The salt, too, dissociates into its constituent anions and cations. It's another video.
So let's bring in another amino acid, and let's look at how amino acids can be bonded together. First, we're going to look at a process called, to do this, in the respect that we have built something. Synthesis means to build. So that's dehydration synthesis. How can we undo what we just got through doing? That process is called hydrolysis.
Strong acids also undergo hydrolysis. For example, dissolving sulfuric acid in water is accompanied by hydrolysis to give hydronium and bisulfate, the sulfuric acid's conjugate base. For a more technical discussion of what occurs, we're going to view the next bubble. Esters and amides. Acid-base catalyzed hydrolysis are very common. One example is the hydrolysis of amides or esters. Their hydrolysis occurs when the nucleophile, a nucleus-seeking agent, for example water or hydroxyl ion, attacks the carbon of the carbonyl group of the ester or amide. In acids, the carbonyl group becomes prototonate, and this leads to a much easier nucleophilic attack. The products for both hydrolysis are compounds with carboxylic acid groups. ATP. Hydrolysis is related to energy metabolism and storage. All living cells require a continual supply of energy for two main purposes: for the biosynthesis of micro and macromolecules, and for the active transport of ions and molecules across cell membranes. It's a video again. Their energy derived from the oxidation of nutrients is not used directly but by means of a complex and long sequence of reactions. It is channeled into a special energy storage molecule, adenosine triphosphate, ATP. Polysaccharides. Monosaccharides can be linked together by glucosidic bonds, which can be cleaved by hydrolysis. Two, three, several, or many monosaccharides thus linked form disaccharides, trisaccharides, oligosaccharides, or polysaccharides, respectively. Enzymes that hydrolyze glycosidic bonds are called glycoside hydrolysis or glycosidases. Another video.
In this video, we'll take a look at how enzymes actually work. The original theory of how enzymes work is called the lock and key theory. We know that enzymes lower the activation energy because of their structure. Each type of enzyme has characteristic ridges, grooves, and pockets that make it unique. Particular pockets that are active in catalyzing the reaction are called active sites. Two substrates come together to form a product, or one large substrate can be broken down to form two products, and that's what we have in this image. Without enzymes, high temperatures would be necessary for this. Each substrate shape fits into its own active site on the enzymes and bonds with the substrates. Bonds within the substrates are then weakened, allowing them to bond with one another or to break, as is the case in this case, forming a new molecule or new products. In the smaller image shown below, we can see two substrates entering an enzyme to form an enzyme-substrate complex, and a new product is formed. If we take a look at the enzyme, it has not changed from the original form. So this is a hallmark of enzymatic reactions, where the enzyme promotes the reaction without actually being involved in the reaction and without being used up in the reaction, so that it can once again catalyze another reaction. Now, an extension of
So, metal aqua ions. Metal ions are Lewis acids, and in aqueous solution they form aqua ions of the general formula. This formula. The aqua ions undergo hydrolysis to a greater or lesser extent. Look at, and that is all.